Question 5, we've got the matrix there, A, which is minus a half, minus root 3 over 2, root 3 over 2, minus a half. Describe fully the single transformation U represented by matrix A. Well, obviously it looks like a rotation. It sort of has numbers in that look rotationally, so it is a rotation. So there's 1 mark for saying rotation. If we remember, our rotation matrix is cos theta minus sine theta, cos theta. And if we can solve these, if we have to, really, we need to solve cos is equal to minus a half, and sine theta is equal to root 3 over 2. So, sine's positive, cosine is negative. That tells us we're in the second quadrant, and if we inverse cos or inverse sine any of those, we will get that theta is equal to 120 degrees. That's 120 degrees, that's a positive angle, so that's telling us we're turning it anti-clockwise. The final part is to say what it's about, which is about the origin. Rotation, 120 degrees, anti-clockwise, about O. Part B, the transformation V represented by the 2 by 2 matrix B is a reflection in the line y equals minus x, 1 mark. It's 1 mark because you should just know the answer. That V is equal to 0, minus 1, 0. I mean, yep, you could go away and work it out from the by thinking about transforming a unit square, but it's much easier to answer those by knowing the answer. Part C, given that U is followed by V, here's the transformation T, find the matrix C, U followed by V. The only thing to get right here is U followed by V, so V goes on the left, and then we can times that, what is it, minus a half minus root 3 over 2, root 3 over 2, a half. We can times those out and we'll get minus root 3 over 2, a half, root 3 over 2. 2 marks. So far, so good. Part D, show that there's a real number k for which the point 1 over k is invariant under T. T is the one we just worked out up here. So matrix C represents T. So that's telling us that there's got to be a point minus root 3 over 2, a half, root 3 over 2, that this point 1 over k is going to be, because it's an invariant point, it's mapped to the point 1 over k. That's going to give us 2 equations, minus root 3 over 2 plus a half k is equal to 1, using the top times the row, column, and using the bottom row times the column, a half plus root 3 over 2 k is equal to k. Once we've got those 2 equations, all we have to do then is solve them to show that there is a point. So we can solve them simultaneously in the usual method, any method you want to solve it simultaneously. But the thing is, when you solve them, sorry, not simultaneously, I take that back. When you solve each equation to show there's a point that works, when we solve this top equation, we will get a half k is equal to 1 plus root 3 over 2. So k is equal to 2 plus root 3. But Now we have to check it works in the second one. You can either do that by subbing it in or solving the second one, but you just have to make sure that getting it once isn't enough. You have to solve it down here as well. If we solve this one as well, then we get 1 plus root 3k is equal to 2k. We can then rearrange that to be 1 equals 2k minus root 3k. So 1 equals k, 2 minus root 3. So a bit short for space down here, but I'm going to fit in this gap. 1 over 2 minus root 3. And then that doesn't quite look like that at the minute, so at that point we now have to well, make it so it's the same, which can be done by timesing it by 2 plus root 3 over 2 plus root 3, and then we can say that does indeed equal to 2 plus root 3. So we get the same value of k from both equations, therefore that means it is an invariant point.